Einstein came up with something very thoughtful, something that I very clearly relate with myself. I do not have any special talents. I'm just passionately curious. Curiosity is something that takes you to the deepest of oceans. It takes you to the tallest of mountains in a quest to look for answers to questions that have been revolving all around in your head. Today, I'll be talking about curiosity and its importance by drawing a parallel expressing its virtues in astronomy. But please don't dive deep into your curious thoughts right now. Please wait for me to complete. Who's a detective? A detective is certainly not a person who was a witness to the crime he's investigating. The detective has to reach the crime scene, collect clues, create a hypothesis based on these clues. The detective then moves further with the investigation on the basis of this hypothesis. The loop continues until the case has been solved. But what if the detective is unable to solve the case? Well, in most of the times, these detectives come up with answers to minor questions within the primordial path of investigation. Now moving to who's an astronomer. An astronomer wasn't present when the Big Bang happened. None of the astronomers have experienced the creation of the sun. So just like the detectives did, these astronomers send probes to the outer space to collect data. They create a theory out of this data and the loop continues. So can't we title astronomers as cosmic detectives? These cosmic detectives study fierce stars. They skim through the cosmos in search for planets. They also look out for deadly asteroids and also study the beauty of the galaxies, black holes. Well, in short, they do astronomy. Astronomy is a science which is at the forefront of science and technology, driving innovation for answering fundamental questions. But how is it that this spark ignites a fire in the minds of these scientists, these astronomers? Around 8 to 9 years ago, these were a few popular shows that really caught my mind. Now, how else would you fascinate a 12-year-old? Definitely not by handing some textbook or showing some raw code, especially in the Linux terminal. What I'm trying to say is that astronomy acts like a gateway. It acts like a bug that actually bites these children and motivates them to take up science. Not necessarily to become astrophysicists, but to become researchers, engineers, doctors, entrepreneurs, innovators. Now, is astronomy just for kids? Let's find out. What is this? A star, the sun. When you look up at the sky, preferably in a place away from city lights, you'll see tiny white dots spotting this black canvas. Are they twinkle, twinkle, little stars? Well, no, they are huge balls of fire, extremely wild and ferocious, definitely not as cute as this. Our planet, Earth, it is less than 30% land, yet this land is enough to shelter over 7 billion people. But when compared with the sun, it's just like a small speck. The Earth is just like a small ball placed on a 15 feet wide yard lawn. You see, the Earth now seems small and the sun seems big. But the sun is neither the biggest nor the brightest star even in our own neighborhood. In fact, it's just one among thousands of billions of stars in the entire galaxy, which in turn is just one galaxy among thousands of billions of galaxies only in our known universe. So I believe astronomy is fascinating for everyone and not just for kids. In fact, astronomy has been a part of us. We've been looking at the stars to navigate through the vast oceans. People used to look up at the stars to plan their crops, harvests. Now, during those days, lived a great thinker, Aristotle. This man used to study shadows. Now, that's such a silly thing to do, isn't it? Who studies shadows? But this man was so deep into his study that he even studied the Earth's shadow falling on the moon during a lunar eclipse. Now, this study of his gave rise to a conclusion, the spherical Earth. This big conclusion created a revolution, not just in science, but also in religion and the society overall. All of you might be wondering that there's one question that really messes with our head. How could a person, a thinker, come up with an idea which was completely different from what the entire society thought? The answer to this is the power of observation, which came into him through the curiosity that he had in his study. We believe acumen is all about reading more books, reading facts, solving behind the book problems. But is it so? This is actually enough to sustain the civilization we are living in, but definitely not enough to nourish it. We need to learn and apply the basic knowledge, the minimal knowledge we have on a larger scale in order to take our civilization a step ahead. I am pretty sure that most of you must have seen these formulas, mostly in your 9th or 10th class. What can you do with this? Can you measure the circumference of the Earth with these formulas? Somebody did. So he was a Greek mathematician. He knew that the sun was never overhead on these two places at the same time. He applied a little trigonometry to calculate the angle that the sun rays made with the surface. After that, he merely had to calculate the distance between the two cities, apply a little geometry, and he eventually calculated the circumference of the Earth. Sounds easy, isn't it? But we couldn't even think of doing this. So these examples of the previous times seem to create a link starting from navigating using astronomy to actually knowing where you stay, from understanding the Earth to be spherical to actually going ahead and measuring it. Well, this was astronomy then. What about now? All of you must have heard of the Opportunity Mars rover. It was in the news recently for vastly surpassing its endurance, expectations in its endurance longevity, and did a lot of research. Well, this rover was a big mission in astronomy. Although the team that built the rover was an engineering team. They sent the rover to Mars, and the rover analyzed summit hills, craters, supposedly dry riverbeds. Coming to the second example, gravitational waves. The theory was given 100 years ago, but the detections were very recent. Why? You might notice that there are two very important key points here. The first is interdisciplinarity. At this time, you cannot assume that you stick to a single domain, and you cannot assume to get all your results within that domain. Just like the Opportunity mission, which had astronomers plan the mission, engineers undertake it, and the rover did neither engineering nor astronomy. In fact, it did geology, chemistry, biology. What this means is endeavors in astronomy and engineering open doors for other fields of science. Now coming to the second important point, technology. Of course, it was a very thoughtful, very intelligent person who came up with the theory of gravitational waves. But it was the curiosity within these generations of scientists for so many years that kept on working hard, working towards proving it. They kept on advancing the technology step by step until they had something perfect. So you see, curiosity is not just about asking big questions. It has also played a major role in advancing a technology. So you might think that curiosity is nice, but is it important? What if I put in a lot of effort? What if I put in all my heart and soul in trying to look out for something? And what if I don't get the answers? What if I don't end my journey? Is it all a waste? We'll talk about this a little later. Until then, let's just talk about smartphones. All of us use smartphones. And I assume the location feature in your smartphone is the one that actually makes it smart. This location feature is somewhat related to the GPS. So let me tell you a story about GPS. Sputnik had just launched. Sputnik, the very first satellite launched by Russia. At that time, two boys in the Johns Hopkins University were very curious. They were very interested about this mission. They thought of tuning into the signal and collecting the data. After some time, they had a sudden change in plan. They thought that with these signals and a little applications of the Doppler's effect, they could actually locate the satellite. They did it. After a few weeks, their boss approached them and said, "Hi boys, you did a wonderful job. But can you do the reverse? What if I give you the location of the satellite? Would you be able to locate me here?" And they said, "Yes, of course. That would be very easy." That is how GPS was born. But when talking about GPS, there's one thing that we need to keep in mind. The satellite is in constant relative motion as compared to the users. Also, it is placed above the surface of the Earth. Now, most of you might not understand this, so I hope you all have seen Interstellar. There was a time dilation just like Interstellar, but at a very, very, very micro level. So to overcome this problem, they had to consider relativity. Now, relativity has always been in our minds something like an abstract thought to understand black holes and all of that in the universe. In fact, all of these big questions, these big concepts, are actually applicable in our day-to-day lives, just like the GPS. Einstein came up with relativity. He was a small kid when his father gifted him a magnetic compass. Einstein was very curious about the deflection of the needle. So he tried to think about this. He used to do multiple thought experiments. And after many years of such thought experiments, he concluded that space and time cannot be considered independently. They are relative. When he did this, calculus played a major role. Let's go a little more deep into the story. So, Newton came up with calculus somewhere around the mid-17th century along with Leibniz independently. So Newton actually never made a formal publication of the entire calculus that he had been working on. We know about his work through smaller publications. Now, what if Newton was to come here? Suppose he traveled in time to listen to my talk. Newton would have been so surprised to see these smartphones. And now, since all of us know that his work played a major role through the links you see in helping Zomato deliver our food on time last night, we would definitely go and thank him for what he had done. So, would he be happy? In fact, he would be very shocked. That's because he didn't know the power of what he had created. In fact, he could have never imagined what we did out of his creation. You see, you might come up with many things in your mind and not get them. But in the process, you might come up with something bigger that you could have never thought of. Here, I think I answered the question I asked a few minutes ago. Yes, curiosity is important. It's okay if you don't reach your goals. It's okay if you don't get the answers. But in this process, you might come up with something remarkable for yourself or perhaps for the entire humankind. If you ask me something, I'll try and answer it. If I don't know the answer, I'll ask my friend. And if both of us don't know the answer, we'll Google it. But what if Google doesn't know the answer? What if nobody knows the answer? Well, in this case, these are the big questions like, does the multiverse exist? Do space and time hold more mysteries? Where did we come from? These are some really big questions that have left this circle incomplete. But in the process of trying to answer these questions, we've been able to fill these small minor gaps. So just like the detective who couldn't complete the case, yet came up with answers to many small questions within the case, we might also come up with many minor questions which would help in completing the circle. Here I would like to conclude and say, it is always nice to have an end to your journey. But in the end, it's the journey that matters. So be curious, enjoy your journey, and complete the circle. Thank you.